Alright, this is APAB Calc. We are doing section 2.5, which is implicit differentiation, and this is our second video. So I'm going to go ahead and start diving into some product rule problems. Okay, so in E3 we're asked to find dy dx, right? Same thing we've been asked to do. And again, you use this when you either shouldn't or can't solve for y, but most of the time you can tell that it's not worth solving for y because the y's are all mixed in inside other functions and it's not pretty. So we have x cubed sine y, that's a product, right? X cubed times the sine of y, times the sine of y equals 5x squared. So when I go to differentiate, right, and again, if you want to write this step where you say, hey, d dx, I want to differentiate, that's fine. If you don't, that's also fine. Lots of people don't write that step. So I spot that this is a product. What's worth noting here is that dv is going to be a chain because when I differentiate stuff that has a y, I'm going to need a dy dx. So I'm going to get u, which is x cubed, dv, and dv is going to have a chain because I need the derivative of sine of stuff. Well, the derivative of sine of stuff is cosine of stuff times the derivative of the stuff, right? This was the derivative of the outside, and then the inside function is the y, right? Plus v, which is sine y. I'm not differentiating, so I don't need to do anything. I'm just recopying what's there, sine y, du, which is going to be a 3x squared, right? Differentiating the x cubed equals, and then on the other side I have a nice happy 10x, and that was nice and friendly. So once I'm here, I then need to solve for dy dx. So in order to do that, remember everybody else just behaves like a number. Since this whole quantity is being added to this expression, I'm going to subtract it over. So if you want to clean it up first, you totally can. I'm not going to. I'm just going to clean it up when I move it over. So I'm going to subtract that over and get a 10x minus, I'll put the 3x squared at the front of the sine y. Okay, so I subtract that over. And then since this is a multiplication, I want to divide that to solve for my dy dx. So my dy dx is going to be a 10x minus 3x squared sine of y all over an x cubed cosine of y. And that's as nice as it gets, right? There's not much better that you can do there. So if you want to try P3 without me, go ahead and hit pause, and I'm going to walk through it now. So again, I have another product rule, right? Here my u is the x to the fourth, and my v is the y cubed, which is going to be a chain rule because it's a y. So when I differentiate with respect to x, I'll need a dy dx. So u is an x to the fourth. dv is going to be a chain, right? It's going to be the derivative of y cubed, which is 3y squared times the derivative of the y, right? Plus v, which is the y cubed. I'm not differentiating the y cubed. I'm just writing it, so that's it. Times du, which is going to be 4x to the third, equals, and then on this side I'm going to differentiate cosine and get negative sine of x. So then again, I want to solve for this. I'm going to do that by subtracting this thing over, which I'll clean it up as I subtract it over. So I have this, I'm going to go ahead and clean this thing up here. I have a 3x to the fourth y squared dy dx, right? Equals, and I'll subtract it and get a negative 4x cubed y cubed. You don't have to put them in that order, but it's kind of typical to put it in alphabetical order. The x usually comes before the y. Doesn't matter. It's not wrong if you don't. And then I'm going to divide this whole thing over to solve for dy dx. So dy dx equals negative 4x cubed y cubed minus sine of x all over 3x to the fourth y squared. Now, again, if you had solved in the opposite direction and moved the dy dx over to the right-hand side, which here there's not a lot of reason to do that because there's only one dy dx in both of these problems and they're already on the left, you would end up with this answer, but with literally every sign being the opposite. So positive, positive, and bottom would have been negative. And over here you would have had negative, positive, negative, right? That's also worth noting because if this ever did come up as a multiple choice question and you don't see your answer, look for an answer that's the same answer, right? That might just be a different way of writing the same answer. Be very cautious about the AP throwing in random negative signs. Sometimes they'll throw in a random negative just to mess with you, to see if they can trap you into falling for a question or falling for an answer that you would have had right if you'd thought a little bit longer, but instead you just went with an answer that looked similar to yours without actually being discerning about it, and it doesn't go well. They're really tricky folks at the College Board. All right, so let's keep going. We're going to talk a little bit about a quotient rule problem because that's good. And after we do a quotient rule problem, we'll go ahead and talk about differentiating another time, right? So we'll talk about differentiating to get the second derivative. Cool. That was 3, right? So E4 and P4. Okay, same thing, we're going to find dy dx, right? So find dy dx, that's our standing arrangement right now. Let's do x squared over e to the 3y, that'll be good, equals 5y plus 2. And on, oh, that's going to be horrible. Cool, I stand by it, let's do this. And let's do an x squared over a y squared equals 6x plus 2y. Great, okay. So this might be totally disgusting. We're going to find out when we do it. This is the problem with me making things up in my head. So this is my high function, and this is my low function. But it's worth noting that the low function is actually a 3-layered chain rule, which is meaner than what I gave you to practice. Because the low function has e to the stuff as the outside function, 3y is the middle function, and then it's y stuff, so dy dx is the outside, or as the inner function. So let's go ahead and do our derivative, right? So low, right, low, didn't differentiate, just copied the low. D high is going to be a 2x minus high, which is x squared. And then d low is going to be kind of messy, right? So this is low d high minus high d low. Now d low is going to be a triple chain, right? Which is not a math thing, but it's not a math term, but you know. So it's going to be a triple chain. It's going to be the derivative of e to the stuff, which is e to the stuff, times the derivative of the 3y, which is a 3, times the derivative of the y, which is dy dx, right? Draw the line, square the low, so that'll be e to the 3y quantity squared, okay? And on the other side, when I differentiate, I'm going to get a 5 dy dx because I was differentiating y stuff, plus 0 because the 2 would be gone, right? So it seems to me that what's going to happen is I'm going to get, this is super fun, I'm going to get a 2x e to the 3y minus a 3 x squared e to the 3y dy dx over what seems to be an e to the 6y equals a 5 dy dx. And I want to solve for dy dx, of which there are 2 of them. So there are a couple options here. I'm going to suggest that if I want, I could cancel out, I could factor out a GCF of this 3y, right, or I'm sorry, e to the 3y, and I could cancel it. You don't have to spot that, and if you don't spot it, it's not a big deal. You could just multiply the e to the 6y over, but for the record, you could actually cancel out these e's if you so chose. Maybe you don't choose to do that, and this is going to take us a fair amount of space, so I'm just going to understand that we will probably eat up our P4 space, and we'll fix it in a second. So there are 2 ways to do this. Let's say you don't spot that you could factor out an e to the 3y. You'd multiply the e to the 6y over, so you get 2x e to the 3y minus 3x squared e to the 3y dy dx equals a 5 e to the 6y dy dx. You want all your dy dx's on one side. In this case, it really makes a lot of sense to just move all of them to this side since this side only has a dy dx. So I'm going to get 2x e to the 3y equals a 5 e to the 6y dy dx plus a 3x squared e to the 3y dy dx. And it became a plus because I added this thing over to the other side, right? It was already a minus, so to move it, I added it over. Now I can factor out that dy dx, right? So I'd get 2x e to the 3y equals dy dx times everything else that's left, which is a 5 e to the 6y plus 3x squared e to the 3y. And then I could divide that over. So I would get that my answer is 2x e to the 3y over a 5e to the 6y plus 3x squared e to the 3y, and that's my answer. Now what I'd point out is even if you get here, you can factor out an e to the 3y from the bottom. If you did that, if you factored out an e to the 3y from the bottom, you could take out an e to the 3y on the top and be left with just a 2x, and on the bottom you could take out the e to the 3y and be left with a 5 e to the 3y plus 3x squared. And then these guys would cancel. So this is the other way you might see this answer. I would say either is fine. Now that's a super awful problem, right? Even when I wrote it, I was like, oh, it's going to be bad. I don't think you're going to see one that's that particularly nasty. But that's the idea, is that there was a quotient. I wasn't able to easily solve for y. So here's what happened, right? I'm going to erase all of this monstrosity, and you're going to get to try P4. You can pause me now if you want before I erase if you want to try P4. I will say that I don't think P4 is anywhere near as bad as the one that we just did. But yeah, so, and there's also an interesting option that maybe some of you saw here. Maybe some of you thought, hey, I don't love a quotient rule. What if I just multiplied the 3y over, the e to the 3y over before I started, and then made it into a product rule here? And that's not a bad idea. Like, that's definitely an option. Like here, if you really hated the quotient rule, you could multiply the y squared over and make this a 6xy squared, which would require a product rule, and a 2y to the third, which would not. Right, so there are definitely other options, but I'm gonna do P4 as a quotient rule. Again, if you want to do it without me, you can go ahead and pause me. All right. Okay, cool. So I'm gonna do P4. Here's my high function, right? Here's my low function. My low function will be a chain by default because of the y's. So I'm gonna go ahead and just assume I'll start it over here. So low d high, right? So low d high minus high d low is going to be a 2y to the first times the derivative of the y stuff. Draw the line, square the low would be y squared squared, which is y to the fourth. On the other side, derivative of 6x is a 6, and the derivative of 2y would be a 2 dy dx, right? So again, I want to solve for the dy dx's. The best way to do that is to multiply this y to the fourth over, right? So I'm going to get y, I'll probably clean this up while I'm working and make this a 2xy squared minus a 2x squared y dy dx equals, and on the other side, this will become a 6y to the fourth plus a 2y to the fourth dy dx, right? Now I want all of these guys on the same side. It doesn't matter which of the two sides you want. Since at this point there's some of them on either side, it really could not possibly matter less. In this case, I guess I'll just go right. I'll move this guy over, which means I'll move this guy over. So on this side, I'm going to get a 2xy squared minus 6y to the fourth. And on that side, I'm going to have a 2y to the fourth dy dx plus a 2x squared y dy dx. It became plus because I added this to the other side, just like the 6 became negative because I moved it to the left-hand side. Now I can factor out that dy dx, right? And what's going to happen, if we come up here, is I'm going to get 2xy squared minus 6y to the fourth equals dy dx times everything that's left in here, which is not a dy dx, so 2y to the fourth plus 2x squared y. Cool? 2y to the fourth, yep, okay, and then I'm going to divide that guy over. So I'm going to get a 2xy squared minus 6y to the fourth over a 2y to the fourth plus 2xy, x squared y, sorry. Now, that answer's right. That said, if you saw this on an AP, it's very, very likely that they would probably clean that up. Also, keep in mind, if you'd moved everything to the other side, you'd be looking at exactly the opposite signs. So a minus, a plus, and then minus and a minus, right? That would be the same answer. So so just be mindful that that's the same answer. But if you really did see this, it would probably either be multiple choice or it would be a free response where you were asked to show that dy dx is equal to something. So what's likely to happen if you see this is you are likely to see an answer that would take out some y's and some 2's. If you notice, you can yank out, like you can factor from the top, right, a 2 and a y squared from the top. And if you do that, you're left with an xy squared minus 3y squared, right? Because the 2 takes that 2 out, which is why it's gone. The x didn't move. You took 2 of the y's. You took out the 2, so now this is a 3, and you took out 2 of the y's. On the bottom, you would be able to take out a GCF of a 2 and a y. 2y. So you'd be left with y cubed plus x squared. So it's likely that the 2's are going to cancel and that one of the y's is going to cancel. So you're probably going to see this answer as a y times xy squared minus 3y squared over y cubed plus x squared, or with the y distributed back in. Now, that's not to say that I really care if your answer looks like either of those things. Remember, it's not, at this point in math, you are largely simplifying selfishly. Meaning you're simplifying either because you're going to have to use the answer again in some way, and this might be an easier version of the answer to use than this, or because you're trying to match your answer to something else, whether it's an example, whether it's a multiple choice problem where you have to match to whichever answer is the one that looks like yours, or whether it's a free response where they say, show that dy dx equals this, and then if you stopped here, they would say, but you didn't show that these are the same. So really, we're not simplifying just because I tell you to now. You're simplifying based on the circumstances and whether it benefits you to do so. If you could have this answer and pick a multiple choice answer that looks like this without doing a lot of work in your head, awesome, congrats. So really, don't just simplify blindly. stop and think, hey, is this good enough? Does this answer the question? Oh, I have to match an answer multiple choice wise, then okay, I have to do a little more work. Stop once you've hit a right answer. Don't do extra work that you don't have to do. All right, cool. Before we go into doing second derivatives implicitly, let's do the classic tangent line problem. All right, so in example 5, I'm going to give you x squared y equals, let's say, 12. Okay. And I'm going to ask you to find the equation of the tangent line at x equals 2. For P5, we're going to do 3x squared plus y cubed equals 2. And we're going to find the equation of the tangent line at x equals -1. Okay, cool. Let's do some math. Okay, so before you get all concerned about this being a difficult problem, right? The first thing we should look at is, what are we being asked to do at the end? The end of this problem is find the equation of a tangent line. So as soon as you hear find the equation of a line, your brain should think 3 things. 1, you need a point, of which you have half right now. You have 2 comma blank, right? 2, you need a slope. And your brain should be like, oh, that's dy dx evaluated when x is 2, right? That's what that long vertical bar means. Dy dx with that long vertical bar, x equals 2 means evaluated at x equals 2. And then 3, I need to write my answer in point slope. So, once I know that's what I'm doing, the first thing I should do is the easiest. The easiest thing to do here is to find the y-coordinate if x is 2. So let's go ahead and find that point first. The reason I say that's the easiest is that's an algebra skill, right? So even if you're panicked, even if you feel like you never learned a minute of calculus, even if you go completely blank on a test, take a deep breath and know that you know enough to make some forward progress. Once you do one part right, it's going to build confidence and you're more likely to be able to do the second part. So easiest part is to find the point. Well, that means plugging in x is 2. So that's going to be 4y equals 12. And just like that, you got that y is 3. So congrats, you have the point 2 comma 3. Yay! Okay. The next thing you need is a slope. To find that slope, you need to differentiate. So I know that I have x squared y equals 12. There are actually 2 ways to do this. There's always somebody that realizes that this is actually a really easy problem to solve for y. So you could do this implicitly with the product rule. You could either do the product rule and do this implicitly, or, because this one's an easy one to solve for y, you could just divide by the x squared and recognize that you're actually differentiating this. Now, this is clearly the easier option here. I didn't actually notice it when I wrote the problem. My bad. Okay? It's not going to work as well in some other cases, but here it's pretty easy to solve for y. So either one's fine, okay? If you choose this direction, which honestly, if I saw this in a test, I would totally be like, yo, I could do this without any work. Okay, so my dy dx, or my y prime, right, would be drop the -2 down, so I get -24x to the -3rd. So I would probably just be like, cool, here we are, I'm done, right? If you did it using the product rule, you're going to get the same thing. It's going to take a little bit longer. Right, if you did it this way, you'd get u, which is x squared. dv would be derive the y with respect to x, plus v du equals 0, right? And then if you solve for your dy dx, you'd get that dy dx is going to be -2xy, because you'd subtract that over and divide by the x squared. So you'd get -2y over x. And you might be saying, cool, Hogan, but how is that the same answer as this? Well, the funny thing is you know what y is, right? Y was 12 over x squared. So either way, honestly, if you did this, you would probably do dy dx evaluated at the point 2 comma 3. If you did that, you'd get -2 times 3 over a 2, and you'd get a slope of -3. If you do it this way, your dy dx would just be evaluated when x is 2, right? And it's going to be a negative 24 over 8, right, which is a negative 3. Either way you went, you get a slope of negative 3. So it really doesn't matter to me which one you do. I'm going to give myself a little bit of room over here. So now all I need is an answer, right? I have my point, 2, 3. I have my tangent slope, which is negative 3. So my answer is y minus the y value equals m, and then the quantity x minus the x value. And this is my answer. If you wanted to solve for y, you should add the 3 over to the end of the thing, but not do anything else, okay? So that's what we're looking at. So one of the reasons the tangent line problem is a really good question is it actually tests a whole bunch of your skills. It tests your ability to do algebra, right? Can you plug in to find a value? It tests your calculus knowledge, whether it was using the product rule and implicit differentiation, or your ability to use algebra to rewrite and then do explicit differentiation. It tests your knowledge of knowing that you have to differentiate, because again, as we move forward, the hard part of this class is not the individual skills. You're probably going to get good at the chain rule. You're probably going to get good at implicit differentiation. What's hard is knowing when to do things. At no point in this problem did I say differentiate. I never said the word derivative, right? I never even said the word slope. I had to know that the tangent line required a point and a slope. So keep in mind that the harder part of this class is not the individual skills. It's putting the pieces together, right? Okay, so I'm going to let you try P5. You go ahead and pause me if you want. I'm going to erase E5 so I have some room to work. And P5 will be the last one in this video, and then we'll go ahead and talk about differentiation again when we use implicit. So I'm going to go ahead and walk through P5. I guess I can probably erase my other part of E5. Okay, so again, I need 3 things, right? Point, slope, and answer, right? I know that the point is negative 1 comma blank, right? I'm going to find that by plugging into this original function, and I'm going to get 3 plus y cubed equals 2. Y cubed is a negative 1. Oh, cool. Y is also a negative 1. Okay, so I have a point, negative 1, negative 1. I need a slope. Well, that slope is going to involve differentiating. So when I go to derive 3x squared plus y cubed equals 2, this is just a sum. I just derived the pieces, right? 3x squared is going to become a 6x, right? Plus y cubed is going to be one of those chain rules, right? Because the y is inside the cube. So it's going to be the derivative of stuff cubed, which is 3 stuff to the second, times the derivative of the stuff. And then the 2 derives away to 0, which, by the way, is a huge trap that a lot of us miss. I can't even tell you how many times at least one of you is going to write a 2 here by accident. And then when you get your test back or your homework back, you're just going to, totally, face palm, because you're going to be like, oh my gosh, I can't believe it did that. I know it's 0. So you're going to do it. Just, it's not great, but it is what it is. Okay, so I want to solve for dy dx. So I'm going to get 3y squared dy dx equals negative 6x. I'm going to divide by the 3y squared. So I'm going to get dy dx equals negative 6x over 3y squared. Now you can simplify this if you want, or you can just go ahead and plug in those negative 1s, right? So my slope is going to be my dy dx evaluated at negative 1, which is going to be a positive 6 on top of a 3 times a 1. So I get a slope of 2, right? That means my tangent slope is a 2. Well, I now have a slope, and I have a point, which means I have an answer, right? My answer is going to be y minus the y value, which will be plus a 1, because y minus negative 1, equals my slope, 2x plus a 1. Or if you want, you can subtract that negative 1, or subtract the 1 over. I don't care. You're rarely going to be asked to solve for y. Most of the time, this is what they want. Occasionally, they'll ask you to solve for y, and if you do, you should do the laziest thing possible. Please don't bother to turn things into slope-intercept. It's just a waste of your time, and I promise that at least once you personally are going to add wrong if you change things to slope-intercept. You're going to do it. I've done it. Everyone I know has done it. Doesn't matter how good you are at math. And you're going to add wrong, and you're going to take a right answer and turn it into a wrong answer. So limit the amount of math you're doing. Do exactly the bare minimum required to get to the answer that is requested. Don't do anything extra. Because we all make dumb mistakes. The better you get at math, the dumber the mistakes you make. All right, that's it for this video. We'll do second derivatives in the next one.